All right, we are going to do a set of review exercises before you work practice 6-5 Form G on your own. This is just to help us remember those things that we talked about yesterday. It says, for what value of x is the figure the given special parallelogram? Show your work in the margins. All right, so for me, I recognize they are saying that this is a rectangle. So I did this. I marked all 4 of my pieces congruent to each other. That's what I need to know. Once I mark these pieces congruent to each other, then I understand I can write an equation. And the reason I can do that is because diagonals are congruent and they bisect each other. So 5x minus 15 equals 3x plus 9. I subtracted the 3x, I added the 15, and I got x was 12. Why did I do that? Because in a rectangle, the diagonals are congruent to start with. When they bisect each other, I get 4 pieces that are equal. So these 2 pieces, their measures are equal to each other. In my next figure, I have a rhombus. And when I looked at it initially, I was like, what am I supposed to do? But then I looked down here and I'm like, oh, they're telling me this angle PMN measures 110. So I kind of put that up there so I wouldn't forget it. But I'm in a rhombus, and I have to remember that one diagonal in a rhombus bisects that angle in the original rhombus. So that 110 angle gets divided by 2. So that angle is now 2 angles that measure 55. And I marked my picture just so I can remember that. So 5x is equal to 55. So x would be 11. Now I'm supporting everything that I'm doing with a reason or a theorem. Right, when I look at this rhombus, this looks kind of complicated, but because these angles don't relate to each other, there's nothing I can do about these. Now if I knew this angle, I could add up the 3 angles to be 180, but I just remembered that right up here a diagonal bisects, so all 4 of these angles are congruent. So that's what's going on here. This angle, this angle, this angle, this angle. All of those angles that lie along that diagonal are congruent to each other. So the angles along a diagonal are congruent, and now I know that this angle measures 2x minus 1, just like this one. I have 3 angles that make up a triangle, so I'm using that triangle angle sum theorem. So I'm adding them. 2x minus 1, another 2x minus 1, and this 4x plus 28. When I simplify, 2, 2, 4 gives me 8x, negative 2, positive 28 gives me positive 26. I'm going to subtract and get 158. And when I divide, I don't get a nice whole number. I get 19.25. The next figure says a square. A square is very simple, y'all. A square has a 90-degree angle here. A square is a rhombus. When you put a diagonal through the opposite angles, it bisects the angles. So what was originally a 90 becomes 2 45-degree angles. So the only thing I have marked in this problem is that angle right there is 7x plus 3. So that angle actually measures 45. So 7x would equal 242. So x would be 6. Remember, that's a square. That corner measures 90. That diagonal bisects it. So it makes each one of these, all 4 of those, turn into 45 degrees. Down here I have another rectangle. And I started marking my diagonals, but that really wasn't what was going to be helpful because my values are here on these angles. Now these angles are not getting bisected in a rectangle. They are not getting bisected. But what I have to remember is that in that corner there's a 90-degree angle at each corner. So these two angles together are complementary or add up to be 90. So 2x minus 12 plus x plus 2 equals 90. When I simplify, I get 5x minus 10. 5x is 100, so x would be 20. Now all they're asking us to do is find the value of x. We're not finding the value of the angles. But if they ask us to do that, we could plug it in and answer that part too. All right, here's a rhombus. A rhombus has so many different particulars questions they could ask. Don't know if you remember, but if this is a rhombus, which it says it is, the diagonals are perpendicular. So that angle right there measures 90. I've got 1, 2, 3 angles in a triangle. So that means they have to add up to be 180. Perpendicular diagonals make a 90. The 3 angles have to add up to be 180. So I set those angles equal to each other. I set those angles adding up to equal 180. So 90 plus 7x minus 5 plus 2x minus 13 is equal to 180. Now, be careful when you simplify. This is 90, negative 5, and a negative 13, which gives you a positive 72. 7 and 2 makes 9x. I subtracted that 72 from both sides and got 108 divided by 9, and x was 12. I'm working with a rectangle, and this is the third rectangle problem, but it works totally different than the other two. I am marking my diagonals because that helps me remember something. All 4 pieces of the diagonals are congruent. Right here is an isosceles triangle. Can you see it? 2 sides are congruent in just this triangle right here. So these are the base angles, or angles opposite congruent sides or equal to each other. So this is an isosceles triangle with base angles that are congruent. So I would set those equal to each other, and then I would subtract the 5x from both sides, subtract the 3, so x would be 10. I had 3 rectangle problems, and each one of them worked differently than the other. Lastly, I have this one about a rhombus, and it's still a little bit different from the rest of them. I have the same situation. The diagonals are perpendicular, so I put my 90-degree angle there. If I knew what that angle was, I could add these 3 angles up to be 180. But I got to think about it for a minute. The diagonal cuts the angle into 2 congruent angles. So these angles along the diagonal are congruent. So I can bring that 2x plus 10 to this place right here, or position right here. So now I have 3 angles in a triangle that should equal 180. So 90 plus 2x plus 10 plus 3x plus 5 should equal 180. When I add up my numbers, 90 plus 10 plus 5 would be 105. When I add up my x's, I get 5x equals 180. Subtract 105 and I get 75. So x would be 15. So I'm going to stop at this point, and then I'll do a second video for the second half of the review.